part 1 of 1.5, solving quadratic equations. You can see a warm-up question there from our last section, so please hit pause, solve that, and then come back and see if you got that answer correct. All right, so the first thing we should do when we're dividing is to multiply by the conjugate in both the numerator and denominator. Conjugate is keeping this first value, our real number, the same, changing the imaginary number to its opposite. So multiplying by 3 minus I. We want to group all of these so that we can FOIL. So our numerator is 6 minus 2i plus 12i minus 4i squared over 9 minus 3i plus 3i minus I squared. Simplifying that, we can take the 6 plus this value. Remember, I squared is -1, so I squared being -1 times -4, this gives us a positive 4 right here. So 6 and a positive 4 is 10. -2 and 12 would also be 10. Oops, positive 10. And in our denominator, our middle numbers go away. -I squared, that's -1 times -1, so that's a positive 1. 9 plus positive 1 is 10. Then we just need to simplify. Divide 10, 10, and 10 all by 10, which leaves us with 1 plus I. All right, so today we're going to be solving by factoring. There should be a lot of review here because we've already covered factoring a lot in chapter R. The only thing we're going to do now is take the things the factors that we find and use those to solve using the zero product property. So just kind of a reminder, when you see a difference of squares, a squared minus b squared, that always factors to a plus b times a minus b. So this first one is an example of that. This is a difference of squares, so we're going to take the square root of 16, which is 4, the square root of x squared, which is x, and the square root of 25, which is 5. Okay, so then that gives us 4x plus 5 times 4x minus 5. Just like that difference of square pattern we have up there. Now this is equal to 0, and the equal to 0 part is what's new for us. We've already done the factoring before, but it wasn't equal to anything. When it's equal to 0, that tells us that one of these factors has to be 0. So all we do is we take each factor and set it equal to 0, and then we solve for x. So subtract 5 and divide by 4 gives us x equals -5/4. So add 5 and divide by 4 gives us a positive 5/4. So x could be -5/4 or positive 5/4. So using that zero product property, we come up with 2 answers there potentially for x. Either one of those could make it equal to 0. Now number 2 is not a perfect square when we look at it. 6 can't take the square root of that, 18 can't take the square root of that, but when we are factoring, we should always look for a GCF first, and this one is no different. So there's a GCF that goes into both of these, and that would be 6x. When we factor out a 6x, we have x minus 3, and then we're going to set each one of those equal to 0, just like we did up above. So 6x equals 0, and x minus 3 equals 0. So we solve for x here, divide both sides by 6, x equals 0, and add 3, x equals 3. Again, 2 answers for what x could be. Number 3 is a trinomial that we need to factor. Find something that multiplies to get 20 and -20 and adds to get -8. So we can think through the factors of negative 20. Some of you have told me that this is kind of your stumbling block. Well, you can always start with, you do like 1 and negative 20. Then go to 2 and negative 10. 3 doesn't go in. You can do 4 and negative 5. And you just keep going until you find a pair that works. Well, we actually already did. 2 and negative 10 add up to negative 8. So we know that we're going to have x plus 2 and x minus 10. We don't have to split the middle on this one because the leading coefficient is 1. But then we want to set each of those equal to 0. So x plus 2 equals 0 and x minus 10 equals 0. So x equals negative 2 and x equals 10. So the only part that is new to us on this is just setting those factors equal to 0 and solving. All right, this is our last one. Go ahead and hit pause, give it a try, and then come back and see if you got it right. This is another difference of squares. So we have to start by taking the square root. Square root of 4 is 2, square root of x squared is x, square root of 9 is 3. So we factor that to 2x plus 3, 2x minus 3. Set it equal to 0. And then take each factor and set it equal to 0. Solve for x. We're going to subtract 3 and divide by 2. Oops, that's a 3. Same thing over here, except that we're adding 3 and then dividing by 2. So our answers that we get are negative 3 halves and positive 3 halves. So when it asks us to solve by factoring, we can use lots of different methods, like difference of squares, GCF, just factoring a trinomial, and we'll do even more in part 2.